So I'm going to work quickly through an example of a multinomial logit and conditional logit regression in data. And this is going to be an example that you have seen before, but I'm going to show you a little bit of the data manipulation that you may have to go through to get the data in order to run the regressions depending on which model you choose. If you use a multinomial logit, the data set can be structured one of two ways, but if you want to run the conditional logit, the data have to be formatted in a slightly different way. But that way also allows you to estimate the multinomial logit. So depending on how the data comes, you might be able to estimate one model or both. But I'll show you how to transform the data set so you can estimate either model that you want. Okay. So let's just load the data set. And notice we have data on 1,182 individuals. So the information that we have in this data set is we know the mode of fishing that they chose. So did they choose a charter, private, pier, or the beach? So those are the four options. We also have information on the catch rates at each of those. So in this data set, the Q variable represents catch rate. So this is the catch rate at the beach, the catch rate at the pier, the catch rate for private, and the catch rate for charter. We also know the price. So we know the price of fishing at the beach, the price of fishing at the pier, the price of fishing for private, and the price of fishing at charter. And we also know their income in thousands. So this is monthly income in thousands of dollars. So we have all that information and we know which choice they made. So this variable over here, mode, tells us that they chose charter. Notice this is blue. That means this is a numeric variable that has value labels so that it's easier to read. But notice behind charter there's actually a 4, behind private there's a 3. So this is a numeric variable. It just has a display a display or a value label. And notice we have a couple other variables that are going to be useful when we go to transform this data set. We have a variable d beach, which is equal to 1 if they chose the beach, 0 otherwise. D pier, defined the same way, private and also charter. And notice this is equal to 1 for this first observation because this person chose the charter. This person chose private, this person chose pier, this individual chose beach. So depending on the model you want to estimate, you might be able to use the data in wide format like this. Notice we say wide format because every row is an individual and columns tell us, kind of describe their actions, versus a long data set where we have multiple observations per individual with the different choices and then a dummy variable indicating which one they chose. And I'll show you how to transform that in just a second. So let's just go ahead and just clean the data set up a little bit, keep the ones that we want. So these are the variables that we're actually going to be using. And notice I went ahead and kept the mode even though I have dummy variables right here telling me which mode they chose. The reason I want to use this is because we can estimate the multinomial logit with a data set in this format. So just to give you a little bit of intuition, a little bit of insight into what the multinomial logit model is doing, the first thing we want to do is tab the mode variable. And when we do this, we see that about 11% of the individuals fished from the beach, 15% fished from the pier, 35% fished private, and 38 fished charter. So we're going to call these percents the probability of fishing in that mode. Again, I know it says percent, but if we just randomly sampled someone from this data set, about 11% of the time we would get beach, 35% we'd get private, and so on. So we're going to call this probability, just so it kind of matches the notation from an odds ratio or a logged odds setup. So the first thing I want to do is estimate a multinomial logit without any controls. So remember, we always use the multinomial logit when we have binary or when we have a discrete dependent variable where the order is not important. Notice here, beach is 1, peer is 2, private is 3, and charter is 4. We could rearrange this where private was 1, peer was 4, beach was one of the other two numbers. It doesn't matter. The order is irrelevant. So that's why we know we can use the multinomial logit. So I'm going to run the multinomial logit without any independent variables and tell it I want relative risk ratios. This way I get odds ratios, not logged odds. Not the logged, or I get the relative risk, not the log of that. Relative risk and odds ratios are very similar. Technical details may differ, but in practical settings, we're going to use them interchangeably. So notice when we run this multinomial logit, it tells me the relative risk of choosing the beach, peer, private, or charter. And notice charter is the base outcome. So this relative risk is the relative risk of choosing the beach over charter. And notice it's 0.2964. So the relative risk of choosing beach over charter is 0.29. So when we go back and look at these relative probabilities, if we look in our tab table, if you take 11.34 divided by 38.24, you're going to get this number right here. Because what this is actually doing is telling you what is the relative likelihood of choosing beach over charter. Well, 11.34% chose beach compared to 38.4% choosing charter, so that relative risk is 0.29, which means we're less likely to choose beach than we are to choose charter. We're less likely to choose peer over charter, and we're also less likely to choose private over charter, because notice charter is the most popular. Now, if I change this where the base is beach, so now I want beach to be the base category. Notice all of the numbers that we get are going to be greater than 1. Because now what we're doing is we're looking at peer divided by beach. So if we take 15.06 divided by 11.34, this is the number that this is the number that we're going to get. So all the multinomial logit is doing is giving you the relative risk of choosing one category versus the other. And you can choose the base by just typing base and then identifying the number that corresponds to the one that you want omitted. Again, the coefficients look the same, but it's the same model. So now we want to run the multinomial logit with a continuous independent variable. So now we want to know, how does a person's income affect the relative risk of choosing one alternative over the other? So when we run this mlogit, mode is a dependent variable, income is the independent variable, and telling it we want the relative risk, let's just go ahead and, well, if you don't put the base 3, it just chooses one to be the base. Again, I'm not 100% sure how it chooses that, but if you want to choose your base, just tell it which one you want. Well, let me just get rid of this. Let's just go ahead and just do this right here. So we're going to use private as the base. So when we run this, we get a coefficient on income that is less than 1. So anytime you have a relative risk, so when you use the RRR option, and you get coefficients less than 1, it means an increase in that independent variable means you're less likely to choose beach over private. So if we increase an individual's income, the relative risk of choosing beach over private is 0.91, which means, or 0.91, which means it's less than 1. I'm sorry, I'm getting tongue-tied here. It's less than 1, which means increases in income lower the likelihood of choosing beach over private. That's all you really need to know here. It lowers the likelihood that you choose peer over private, and it lowers the probability that you choose charter over private. So higher income people are most likely to go the private route. Again, if we change this base, so let's just go ahead and change this to peer, and peer is base 2, we should get coefficients that are greater than 1. Notice when we use peer as the base, an increase in your income means you're more likely to go to the beach to fish compared to the peer, more likely to go private over peer, and more likely to go charter over peer. So all you're doing when you're looking at the relative risk is comparing it to 1. Greater than 1, more likely, less than 1, less likely. Just like we have in the Logit, we can estimate the margins, so figure out what is the change in the probability that you choose one over the other. So we just do margins, dy dx, income. So this is, I want the change in the, basically the slope of that fitted, in this fitted model with respect to income. And we're telling it we want to assume income is at the mean. And notice increases in income increase the likelihood of choosing option 1, which is beach, decrease the using peer, increase private, and then decrease charter. Now, if you add these up, they will sum to 0. Because if you're more likely to choose one over the other, if you're more likely to choose one, you're less likely to choose the other. So if you add these up, they go to 1. And notice this is a little bit different than what we saw up here, because here when we estimate the margins, or before we estimate the margins, it says an increase in your income makes you more likely to go beach, more likely to go private, more likely to go more likely to go charter relative to peer. Here the signs don't necessarily match what we were seeing above, and that's okay. But all I'm going to expect you to do is look at the estimates and tell me does an increase in that independent variable make you more or less likely to choose that option over the other. Okay. So now I want to show you just a little bit of the data wrangling that's necessary to get this in the format to use the conditional logit. So notice here we have one observation per individual, and then we have 4 variables that identify the choice, 4 variables that tell us the prices, 4 variables that tell us the catch rates, and then a column for income. Now what we want and what we need to estimate the conditional logit so that we can include alternative specific independent variables is we need one column D that tells us whether or not we chose the beach, the peer, private, or charter. We need one variable called price that tells us the price at each option, and one column for the catch rate that tells us the catch rate at each option, and then income is going to be repeated within observation, within an individual, because income does not change within individual. So what we can do is we can use this reshape command. Now we have to generate an ID first. And all this does is it just indexes individuals. So all that did, it just goes from 1 up to 1182, just identifying the individual. What we can do is use this reshape command. This is, I want to take this data set from wide, where we have one observation per individual, and I want to convert it to a data set that's in long format. So now, since we have 4 modes, we are going to have 4 observations per individual. And within those 4 observations, we're going to have a dummy variable equal to 1, indicating the choice. We're going to have the price for each alternative, and we're going to have the catch rate for each alternative. So reshape long, notice I have P, D, and Q. P, the variables that start with P identify the prices. The variables that start with D identify the choice. And the variables that start with Q identify the catch rate. And it's really important that we have the same stub on each one of these. So notice we have D, beach, peer, private, charter. We have P, beach, peer, private, charter. And we have Q, beach, peer, private, charter. And that's what I'm telling Stata right here. These are the variables that I want to convert from wide format to long format. ID represents the individual, and where I have J option, it's going to generate a variable named option for beach, peer, private, and charter. And that's how I'm going to make sure I know what the price is actually measuring. String just tells that the stubs are strings. So this, if you're working with yearly data, this may have been D2000, D2001, D2002, and so on. But because we have beach, peer, private, charter, we have to tell Stata that this is a string. So when we run this reshape command, notice the data got narrower. It's longer, but narrower, which is exactly what the long format is. So notice now for individual 1, right here, we have the 4 options they could have chosen from. So they could have chosen from beach, charter, peer, or private. We know they chose charter, and that's exactly what this variable is indicating. So the D is our choice variable, and for individual 1, that is equal to 1, where option is equal to charter. Individual 2 also chose charter. Individual 3 chose private, because D is equal to 1 where option is equal to private. So that's how we know that the D variable and the option variable are working together here. And we have to use both of these in the conditional Logit model. P, this is the price for beach, price for charter, price for peer, price for private. For individual 2, they face prices of 15 for beach, 34 for charter, 15 for peer, and 10.53 for private. Notice the price and the Q variables vary within an individual. So depending on who you are, depending on the option an individual faces, they're going to have a different price and different catch rate. Notice income is repeated within individual because we only have one observation for their income. So individual 1 has an income of $7,000 a month. Individual 2 has an income of $1.25 thousand per month. So now we have the data in long format, because when we estimate the conditional Logit, the dependent variable has to be equal to 0 or 1. It has to be binary. Where in the multinomial Logit, we have a variable that was 1, 2, 3, and 4. It's discrete, but it uses that order to sort, or the 1s, the 2s, the 3s, and the 4s to identify the choices. Now we're having to identify the choice with a dummy variable D, and then we tell Stata the options, the different choices they could have chosen from. So remember, we use a conditional Logit if we have a data set that has case-specific observations, which would be income. So the case is the individual here. So we have data on their income that does not vary within individual, but we also have the variables P and Q that vary over individuals and over options. Okay. So if we look at P for person 1, it varies, which means this is varying over the alternatives. But if we look at the P for person 2 compared to person 1, it's also different because person 1 and person 2 may have been in different locations. So if you have independent variables that vary over observations and over choices, we want to use the conditional Logit. Again, I'm trying to fix this just so I can come back to that later. So the notation for the conditional Logit is ASC Logit. So alternative specific conditional logit. The dependent variable is D, which is a variable equal to 1 if that option was chosen. P and Q are the alternative specific variables. So P and Q vary over alternative. Case is ID, so this is how we tell the model to separate the individuals. So we have P person 1 through, I think, 1182. Alternatives is the option variable. So this is where we're telling Stata, these are the different options they could have chosen from. So we know individual 1 chose option charter when faced with the choice, beach, charter, peer, or private. Case vars, these are the variables that are individual specific. So income does not vary within an individual, so it's individual specific. Base, I'm telling it, use private as the base, and we want odds ratios. Okay? So when we run this, the output looks similar to the multinomial logit, but we have this extra box up here at the top. And what this extra box up here at the top is telling us is that regardless of the option, if we increase the price, people are less likely to choose that option. The coefficient on catch rate Q says it doesn't matter if it's beach, charter, peer, or private. If we increase the catch rate, we increase the odds of someone choosing that option. Remember, less than 1 means you're less likely to choose it. Greater than 1 means you're more likely to choose it. And now we have coefficients that are similar to what we saw with the multinomial logit. If we increase a person's income, they're less likely to choose beach over private, they're less likely to choose charter over private, and they're less likely to choose peer over private. So these coefficients are, you can interpret in a way that's similar to the multinomial logit, except now we're conditioning on price and the catch rate. That's the main difference. The nice thing about using this ASC logit model is that we can estimate the multinomial logit using the same command. So the multinomial logit is a special case of the conditional logit when we have no alternative specific independent variables. Notice here I have ASC logit D, which means the dependent variable is this choice. What did they choose? Given they had these different alternatives, and now we just want to use their income. So if you have the conditional logit without any alternative specific independent variables, you've estimated a multinomial logit. So if we run this regression right here, this ASC logit without alternative specific independent variables, we get coefficients that are identical to the multinomial logit that we estimated up here. So if we go back, so let me just go back and load this data set so I can run this regression one more time. Notice the coefficient on income with a multinomial logit using the original data set was 0.912. The coefficient on beach, when we use the ASC logit without alternative specific independent variables, it's 0.912. So the multinomial logit is just a special case of the conditional logit, which is why you may want to use this ASC logit command. I mean, your coefficients may be different to the 5th or 6th decimal place or something, but for practical significance, they are identical. It may just be the procedure that Stata uses to estimate the parameters is driving the difference in coefficients. But the main thing I wanted to show you here with this exercise is a lot of the model that you estimate depends on the types of independent variables you have and the type of data that you're working with. If your data is in wide format, you can use the mlogit command. You can estimate the multinomial logit this way. If you have data in long format, you have to use ASC logit command. You can use either one. They're both completely valid, but you just need to make sure you're choosing the appropriate model. Are you including independent variables that are case specific or individual specific? Another way of saying that, do you have variables that describe the person making the choice, or do you have characteristics of the different options from which the person can choose? And if depending on what you have, you may have to estimate the multinomial logit, or you may want to estimate the conditional logit. Okay. So the last thing I have down here at the bottom is just a simple regression with using an ordered logit. So let me just show you just quickly what we have here. Notice we have a data set that tells the person's health status. We have their age, the log of their income, and the number of diseases that the individual has. And notice health status is something that's discrete. In this case, it takes on the value of 1, 2, or 3. Actually, maybe 1, 2, 3, or 4. Let me just double check that. Tab. Well, it only has 3 options: good, excellent, and fair. So we have data on their health, and notice it's labeled behind the scenes here. Good is 2, excellent is 3, and fair is 1. So it's numbered 1, 2, and 3, but the order there matters because excellent health is better than good, and good is better than fair. So when the order matters, you want to estimate the ordered logit. So that command is ologit, dependent variable, which is health status, age, log income. That'll do comma robust, and I'll tell it I want odds ratios. We didn't talk about the standard errors for the multinomial logit and conditional logit, but the main thing there are the coefficients. And notice what we get. We only have one set of output. When we estimated the multinomial logit regressions, notice we get different outputs. So we get a set of output for beach, for peer, for private, which is the base in this case, and charter. When we have a dependent variable that's discrete but order matters, the order logit estimates only give you one coefficient. And all this says is that as your age increases, the odds of saying you're in excellent health are lower than being in good or fair, which means the likelihood or the odds of being in excellent condition or having excellent health status fall with age. Having a higher income increases the odds of having an excellent health status compared to good or fair. So not as much behind the scenes, or not as much to go into for the order logit. But again, make sure you pick the right model. If your independent variable if your dependent variable is discrete but the order matters, use the ordered logit. If order does not matter, you can choose between the conditional logit or the multinomial logit, depending on the type of independent variables that you have. So if you have any questions, feel free to send me an email. I will post this do file on Blackboard so that you can work through this, and I'll also post the data set so that you can follow along with this video.